Thanks for coming out to SDC on this Monday morning. This session is going to go over the SNIA Emerald specifications updates about the enterprise systems and enterprise devices, and then a relaunch of the SNIA Green communities and what we could achieve together if there's volunteers. And I've been a long time with SNIA itself. I've been started in 2002, so I've been part of SNIA ever since. So despite what no employer at this point in time, I've been involved with this green program since its inception. So here's a brief agenda. What I'm going to cover, what's an overview of the SNIA Emerald specifications, where we're at with version 5 at the enterprise system level, and we just achieved quorum. Thank you, John, if you did cast a vote for Kioxia. That helped get us over the top. We were like only 3 votes away. Now the device specification, and then I'll talk a little bit more about what we're trying to get relaunched and a little bit about the birds of a feather session tonight. And so the high level, this program has got started in 2008, and what I want to call out is like the brown block in the middle is what the focus of SNIA has been. Define a test methodology and a specification, and everything that's green boxes, that's up to an organization to define qualifying thresholds. And so we, as an industry association, didn't want to block any potential member, but build relationships and provide methods that were high integrity. And, you know, at the time this got started, every vendor was wrestling with their customer requirement. Tell me how much energy my system consumes. And everyone had their own calculator. And then when we start to compare the different system vendor calculators, we quickly found out some included certain environmental conditions when they tested, or certain workloads, and it was like apples and oranges. And so SNIA went to define a common methodology that would then allow apples to apples to apples baseline comparisons. And at that time, the U.S. Environmental Protection Agency was just getting into data centers, and they'd lumped enterprise storage in with servers. And we said that they're apples and oranges as they were because of the different characteristics. And as you know, there's storage and network, and then the server itself. And so, given SNIA's original mission charter was around network storage, we're looking at everything that was storage outside of the server box itself. So if it had storage in the box, the servers just threw like a 5% adder, and it was adequate at the time because that's what typically was going on, like 2 to 3 hard disk drives in a server box. But then you got into these refrigerator-sized rows of network storage, and so that's where we focused in on, was to go after large data center configurations, and that's how we've retained focus around enterprise storage. We're going to go into more detail, but you know, most importantly is that we've had a variety of programs in place here. We've educated the independent test labs out there, like the MET labs, UL labs, TUV on how to be a certifying body, on how to look at test results if you self-test, or if they go into a lab. We've had qualifications for independent labs to try and provide some consistency. When we first start training, we set up a 4-day class for labs and testers, because a lot of times the architects inside the system vendors are not the testing department that does the regulatory testing. Mostly at that time it was about EMI and acoustics and things like that, and then as we moved into power, some of those same departments picked up power. And then at the time, some of the largest Fortune 50 companies were able to take on their testing as well because they had unique characteristics. Like you got in the banking, they weren't looking for the most energy efficient system, they were looking at a high redundancy system. So if you had a system full of all these systems that went to sleep, that fit like a data archiving environment. A bank that's doing transactional computing that has to do seconds, like you're at the gas pump or a point of sale, it holds two different type of configurations. And so we set up the basic testing methodology without getting into vertical industry testing. And then on the far side is the number of different countries that have become involved in referencing these specifications over time. And then as I talk more, we'll get into where we're at now with China coming into the fold now too with some of the work they've started. So, as I said, we've had this focus since 2008. We came out with our first, this is the overview, a little bit of history here, no quiz at the end. We started in 2008, and we spent like 6 years looking at requirements using test tools like VD Bench, and we had our technology center at a point in time, and all the vendors would bring your systems in. We had tape libraries, we had low-end storage, we had NAS, we had block I/O, we had the type of systems that had drives that went to sleep, and we start to characterize them all these systems, and we had like 6 different test methodologies based upon what type of system that you had. And then over time, the industry's drifted into looking at just online storage and near online storage. No one really wanted to characterize every type of storage device in a data center. So at a point in time, we had like object systems in there. We were going to characterize network type of devices, redundancy, and software-defined storage. And as we have evolved, we've seen that it gets too complicated for the regulatory bodies. They tend to outsource the knowledge to some other subject matter expertise to try and write a specification, and many times they fall short of understanding what it is. And so, not trying to say SNIA is the only place where there's great expertise, but the one place where most of the subject matter experts convene is in SNIA, because they have all this in-house knowledge of how they characterize their customer workloads, understand system behavior, understand a lot of energy-saving techniques around capacity optimization, compression, thin provisioning, and that. So again, the focus has been on the block, the brown block there, and the way how SNIA has organized technical work groups write the specifications, but how do you roll out a whole program? So at a point in time, we had a focus on raising supplementary funds to build a whole program, educate industry, build alliances with industry regulatory bodies, and then do a whole bunch of other best practices around the data center. And then we started in 2003 or 2 with the whole idea that the highest end of systems are so expensive to test that you can't move them around, and they can run like $1 million just to put a configuration together. And if it's a Cisco system, it might be $2 million because it's redundant. But that was just a little joke there. So I looked at the use case needs for hypervisors, the big cloud vendors, and the highest end systems to say, if these become so expensive to configure and they're so unique to the customer they're shipping to, how do we still provide a procurement set of guidance for the enterprise data center? So we've started on the device-specific area as well, and we'll talk about that. So gives you a little bit of structure of how we organize the work inside of SNIA, and then the type of alliances work that we've done to work outside of SNIA. Because our work has become integral with regulatory bodies, and when they write their regulations and update them, we had to become more predictable about our own specifications so that vendors could time their product lines with regulatory needs and not disrupt revenue sales going into geographies. And so 2 times a year we put out a roadmap. What I haven't circled in red is the 2 specifications of how we develop them, test them, and then we eventually submit them to ISO to become useful at a worldwide level. When we start with our first set of specifications, because we're an industry association here in the United States, companies outside the U.S. as well, they could change that specification within, the next 6 months, and they were looking for multi-year reliability of referencing an ISO spec. And so that's what we've done, is that we will take certain versions to the ISO level so that there's a common baseline. You get into like a global corporation, they want to set standards for all their data centers to operate the same way or procure the same type of configurations, because there might be failover data centers and so forth. So, but when you get into that other geography, they want the stability of ISO. So that's part of our roadmap as well. But we adhere to that, and that helps vendors know how to engage SNIA as well on if they want to be part of our test definition and test validation methods as well. So we usually have about anywhere from 24 to 36 month outlook. And then when we do a stakeholder meetings with regulatory bodies, we add them to the roadmap, because once we come out that building block, they need to layer in a set of thresholds and then work with certifying bodies and other type of reporting mechanisms that might regulate what's allowed into that geography or what's reported in that geography if it's not compulsory. And so we've been working on we've had the version 4 out for some time now, and we'll see that over the last 3 plus 4 years, we have there's 9 vendors that have tested over 100 systems with system reports out there for that from a procurement standpoint. So this is the work we started a year and a half ago to update into version 5. The biggest thing that we were finding is we were looking at tool lifecycle management, and VD Bench is a very useful tool, but it's a like semi-open source tool that Oracle has, and Oracle has been less predictable about their support and how long they will keep it out there. So we've made some tough decisions to say, it costs too much for us to come up with a workload generator ourselves. It's better to take an existing one and then adapt it, and then get some lock-ins on the forward-looking time frame that they will be available. So we did a lot of work to look at, can we use another tool and get within 5% of what VD Bench does. And so we worked with Calypso Systems, and we've created a special version called CTS Lite. Special meaning it's all the same functionality, but those that understand like what a crippled system or a less feature-rich system, there's that version without having 2 different families of product. And that's what we're replacing VD Bench with 5.0. And then on the File I/O workload, spec already has a lifecycle management around their File I/O workload tools under what's been now being called spec storage. And they've change the workloads based upon how the industry is shifting. So, like the architecture you just described in your prior session around AI's come on real strong, but the question still is what vertical industry is your AI being defined for? Because that dictates what the file I/O would be with. So everything with the file I/O is more a vertical or horizontal type of application measurement. Everything at the block I/O is just I/Os, whether it's coming in as a backup system or restore, or it's a random workload under transactional processing. So how we get some of the work done, we also partner with group stakeholders. So we work with the Green Grid Alliance, who works with Digital Europe, and they work with European Union Lot 9. And then more recently, we started a relationship with ETSI, and they tend to focus in on the European market for telecommunications. And then because they're looking at specification, it has a large definition and set of work that's come through Huawei and the Chinese National Institute of Standards. That's also, Huawei's working backwards with some of the things, because they had lined everything under version 4 right now under ETSI, and we said by the time you're done with your work in ETSI, we're going to be out with 5, and we were looking at retiring 4, so we're getting our timelines resynced up, and the work we plan to do with ETSI and SNIA will be around version 5 and not the current version 4 work that's going on right now. And then as we move forward, the EPA will then come up with another framework program called data center storage, and it'll be 3.0. But in order to look at how do they set a fair threshold, we do all this data analysis. So I just mentioned that there's over 100 data reports out there of all the vendor systems across 9 different architectures, everything from hard drives, hybrids, drives to 100% solid state. And we do extensive data analysis. And one of the biggest things is there's always this desire to have what I call a single figure merit to say, like we have for automobiles, city and highway for mileage, and the best we can come up with is 5 figures of merit for block I/O, and more or less a set of figures per application workload for the file I/O, and so we continually do that work to see if there's less metrics or less testing that needs to be done to be able to come up with a meaningful prediction of how that system behaves in the data center. So we've done enough work that we still see inconsistencies. The cheapest way to look at a system is let's just do idle, power it on, and let it just collect data. And that's not your best indicator, because we found out some systems do a lot of background work while the system sits idle waiting for active work to come into it. So it's doing block scrubbing, error correction, moving data blocks, removing data around. So it rarely goes idle where it can go to sleep in the enterprise, which is much different than your client system. So we have like 4 active workloads under block I/O, and then we have the idle test. And we have a lot of things that we do with idle that just say we've got to boot up the whole system, load it with data before you can start working it, because you want your whole back end to be active when it enters into the idle state, rather than I powered it up and it doesn't have anything to do at that point in time. So where we're at right now, so this is the last 2 years, this is what we've accomplished on that side of the screen. And then on this side, we still are working through the specification, making sure it's up to date. So we got to rewrite all the test methods under VD Bench and have CTS Lite. inserted in there. And then and then we've been working with the different stakeholders, getting their timelines better lined up with what version 5 is going to deliver them to the marketplace. Right now, the EU Lot 9 is working on the next generation of their regulations. They started out with mostly like power supply ratings was the biggest thing that they had in the prior one, and some level of testing under idle, but they weren't ready to embrace the full version 4.0 specification. So it's, like I said, it's a building block to pick and choose as you see fit. What you want to work with out of the specification, but it's been well vetted within the manufacturers of the system level to say you're not going to have some hard people or application engineers understand the architectures better than the engineers that build them, and they convene here at SNIA. Other work that we do on behalf of the EPA, we're a collection site for their data center shipment data into the U.S. That gives them an indication of how many vendors are creating systems in the United States and what the penetration rate is. So they're trying to, like soften the need to add more power generation systems, and that was easier to say 2 years ago. AI has just turned that whole model upside down, where you got nuclear plants, old coal plants, old water-driven hydro systems in different parts of the country. However, they still want to keep development down. So we help them out with the data collection. Some vendors don't want government regulators into their company's business by product line to maybe impose additional restraints. And so SNIA provides a buffer between the EPA, where we'll aggregate the data, but it doesn't have to be that specific for their reporting of penetration rates of how many systems of a certain configuration were shipped into the market. If maybe once, twice a year, but depending on the agency, we'll hold what's called an industry stakeholder meeting, where we get the vendors together, a couple analysts to give future trend data, and talk about the uptake of their program, of the regulatory program, review our timelines, and then look at future requirements. And so those tend to be meaningful. We also tend to get other parts of corporations that typically are involved with regulatory compliance or writing policy or looking to change and improve government regulation. So that's where it's a stakeholder meeting. It's not all about just those involved with the test specification itself. We've been successful having those with the EPA. I know in the past we used to have them in Japan. When I would travel there, we used to meet with the top runner group that's part of the ministry there. We've had con calls in the past with the European Union Lot 9 and other type of country-specific bodies as well to review roadmaps. And depending on how wide or how small they want to have our participation is how well we'll publicize it. And then on top of that, you end up with all these independent test labs and other types of authorities that can review data in an unbiased way and authenticate it. That is when it's self-test. And they're part of the meeting as well, these meetings as well, because they're also have to have permission from that regulatory body that they can perform that type of technical work with integrity. And then with version 5, there'll be more training. Like if you're new to testing, we have probably about 6 days of taped training online that shows you how to set it up, how to configure it, what your scripts are doing, what your data plot should look like, and then how to calculate your metrics out of that. And so there's a lot there on how to do it, and as with each version we bring out, where it makes sense to improve and change over to training, we do that. version 5 will have a whole new module on block I/O testing because we're moving from VD bench over to Calypso, and the tool has been configured with a lot of extra automation for like one button push installation, and it does a lot more value add data merging between the power meter and the actual I/O collection to calculate your final metrics. Where with VD bench, that was your own. You're getting two sets of data, and then you had to get them synced up and then do your own calculations. And with this new version of that we're moving on to, it's very automated, and it provides real nice graphs where you can go in and look at very specific granularity by the second to look at system behavior as well. So the training becomes very important to understand how the tools can help you optimize your system, and if you don't have it optimally configured to even run the test. And then our plans on 5 is, because it's a new set of tools, is to make it ISO as well. So once you have to get to a point like you have it in the market for about a year, make sure you got all the, you don't have to do any errata or addendums to it, and then move into ISO because they're looking for stability for the next 5 to 7 years to reference it. So that's the work that's part of it. Obviously, if you join SNIA, you get to have fun with it and comment on it and get the inside scoop, so when it comes into market, you're not surprised by it. This is the example of the work we've been doing with the EPA since about 2008 was when we started our first meetings with them, and then we jointly agreed how we would go about developing the specification, separate the server spec. And then this is the second iteration of their test program. This is their version 2, based on version 3 and 4 specifications. Most vendors will spend a little bit of time with the configurations here, but just as a high level, you can see how they grow. So they're looking for enough data to be collected to be able to set thresholds for the next version. And this is, I just went out there this morning, and there hasn't been any new vendors testing, but you can see that as models get retired and new models come in line, that becomes part of our data set that we can then analyze with lots and lots of data to look at, and then we summarize it and then make recommendations for the next program, what thresholds should be set for fairness. So that's this program, and it's all public data. So the test reports that come out of Emerald, and then some extra data that the EPA collects. Each one of those vendors that are in that part of the screen there, you can click on it and get the whole report. You can also export the whole data set and do your own analysis on it. So that's a nice thing. So I know the big thing in this, any time you're writing specifications is how relevant is it? How many people have commercially implemented and adopted it versus is it shelfware and people get the check mark? Well, this is evidence that it has uptake on based upon the reports. So this has now become the green storage community. So this is like the extra things that get wrapped around the technical specification that have to do with policy, alliances, what groups we're working with, and that we work with. So the engineers work on the test and the test methods of validating that over long periods of time, and then the rest of the group inside of SNIA that's focusing on green work the outside program for the testing bodies and the alliances and regulatory bodies, more or less. We also look at requirements that within other technical working sites need to say what should be taken advantage of it. So in the past, we used to work with the storage management group to make sure that there's instrumentation inside of Swordfish in the prior version of SNIA. Working with the S3 twig on data collection, they have tools that you can create your own workloads and that. So we've worked with them. We've worked with the cloud management group as well to say what type of requirements could be driven into cloud vendors. Unfortunately, like the cloud vendors have had to move into a whole different way of how they do reporting and procurement. They make their own systems. EPA wants to look at only what's called a sellable SKU. So when you're building your own systems, it's unique to them, and so they don't have to participate in the system level specification testing. And then, but they're still trying to provide you back how much energy did your service level require, because you bought flexible systems and servers and storage data there. And then inside of our groups too, we have a special package called Enterprise Drive Form Factor, and that was the ability to take a solid state drive and match any type of DPU, GPU, or whatever into the same package, and that would be nice work we wish we could do, but that takes a little bit more coordination between 2 or 3 vendors between the package, the GPU, and the solid state device. But we want to verify that whatever SNIA is creating in one group is also complementary and compatible with other things that we do in other groups. It's a little bit redundant. One thing that we do have is called the IATA repository. It's in conjunction with a lot of universities where they capture a lot of workloads, follow workloads, and those could be future sources of workloads to drive vertical industries that could be then added through the same test tools. So it's just a matter of taking those workloads, validating them that they make sense for more than the one entity that recorded it, but people feel like there's a fair representation, and then we could create that part of a program. And that could be some future work that we have not done a lot with. And then when we get into things like the redfish, swordfish, you talked about measurement, from the Cisco standpoint, once you are in production, how well did you predict what extra levers do you have to adjust your workload while it's in there? And the redfish, swordfish would play into more like what's called the data center information management tools, DSIM, in a generic level to tell you red, green, yellow light that it's time to rebalance your workloads because you've fallen out of spec or what you thought you purchased. It's not behaving the same way as you expected, and that part of industry hasn't come together yet too well between what I call the procurement side of what's the prediction of that system. These tools are better prediction of operational measurements, but they're not, because usually the spec sheets that come out of the systems they're for your worst case scenarios, not for your typical case scenarios, and then your operational data is your actual use case. And so that's it on system level. So we got version 5, and if we go back to the roadmap, it shows that we'll be out in 2026 with it to go for industry vote to become SNIA architecture, and then downstream from there. But the tools that we're working with, CTS Lite, those can be acquired today, as well as Storage SFF. And it takes us a while to get all the data, so there's ways to participate right now to get your organization familiar, so that if you want to be timed when that hits the market, you can do that work today. So this isn't the most comprehensive view. This is Wayne at 5 o'clock in the morning view, remembering what I did a few years ago. And I came up with the idea, it's like, well, we kept on seeing all these one-off designs by the cloud vendors. And I said, well, how do we bring them into the fold with the EPA as we saw enterprise vendors unit shipments going down, but we still make a positive impact for the storage industry. So I looked at from the hypervisor and supply chain standpoint to say if there's big scale-out systems rather than scale up or distributed systems, I says, well, how can the regulatory body put a threshold on something or spec something in the same way you might like spec a power supply? So that was the building block idea I did. I ran a couple industry birds of a feather sessions or market research focus groups, and we found out some companies don't want to see a device level out there. They want to see system level only. Like EPA wants to see it at the wall as sellable SKU, and I said, well, maybe EPA is not the consumer of this device specification, and I felt there could be an apples-to-apples specification that could be out there. But many companies, like say like your IBM and your procuring, they have their own methodology of what workloads they know their customer base has, and they have their own way how they want to evaluate things. But I still felt that there was enough interest. So every time we held a vote, do we keep on moving forward? It just kept on coming up over and over again that about 2/3 of the group said keep on moving forward. So we don't know, the way how some of the mechanics work in the marketplace, when there's revenue on the line, to say you must instead of it's nice to have. When you say you must, or some vendor adopts it, or some regulatory body, then people then start to use it, and they don't really have a good use case of future requirements. And right now, we don't have anyone that's in the what I call you must at this point. But I feel it's on the horizon still. That there's high value of this, what I call lowest common denominator, of what tools to use in some test methods. So there was also this whole issue around testing of large distributed systems, like you'll say, like you're talking about if you want to spread a workload across several data centers and be able to reprioritize data. How do you look at that total configuration? You never will be able to come up with a real power measurement and then benchmark that against an alternative. And so felt like, well, then it starts all the way back at the building block. That's like the power supply, circuits or some of the basic technology. And that's where I see still some merit in looking at the characterization of the drive itself and what its power is and what will be there. And then we haven't evolved the test into, well, what if you then start getting into additional power management features in the stack beyond just the physical device itself, and that could be future requirement work of what we do when you start going up the stack. And the way how we handled that in the system level was we had a whole set of checkbox criteria around capacity optimization tools of does it do compression and provisioning and so on. And there might be as simple as that there's feature sets that are in the device that you can enable. And I just wanted to be clear that this is for the enterprise devices, and because they tend to be running all the time, and client workloads have been well understood since desktop systems have come along, so you can test everything from at the application level as well as the drive level. And they usually have to have additional features like sleep features and other type of power down or almost going to sleep modes. And the test methods that we've developed and the first set of workloads are based on enterprise workloads. So what the first workload that we're using is the Four Corners workload that VD Bench was doing at the system level. When we looked at CTS Lite replacing VD Bench, we said, well, we'll use the Four Corners test as a starting place. That you have to at least have one workload to validate your test methods. But with the company Calypso, they have also an I/O capture tool. So if you want to capture device behavior, any type of behavior, you could then take that captured workload and run it through their workload generator, and you can get a better tailored workload for certain customers or vertical industries by working with that tool in combination with this test methodology. And if there's enough vendor interest to find like 3 vendors all doing, say, like the automotive market's been one of our exploratory areas, then you can bring in an automotive workload, and that becomes part of the device specification. So that's the type of things that SNIA is capable of doing, but we need collaboration and alliances to drive things like that. So we just, over the weekend, we just got to becoming a version 1.0 specification, and then what we have is a lot more outbound work to do around vendor training and regulatory agency awareness now that we're done, and start looking if we need to have a version 1.1 to be relevant for that hard driver that will then help vendors move forward with it. But it's here, it's now, and it's available. So some people have never heard of it before, or the company that we've been working with is Calypso Test Systems, and they took their core product for the Calypso Test Suite, CTS, so we created a very narrow set of the feature set that is in it to just do the workload generator, get a better price point if you have to have multiple seats just in your regulatory department instead of the full-blown package that you might have in your engineering department that's working on future design requirements and looking at a lot more things. So they just need to run the workload component of it, but to get good test tool automation and make them efficient. So the others, like your typical block diagram of what the test harness looks like, and there's a whole new set of technology that at the system level that we're becoming aware of, is that there's tester boards and modules that test an individual device. The company we've been working with today is Quartz, and they also have a lot of automation in there as well. And we've been able to integrate the CTS Lite tool with the Quartz tool, that if you put the configurations together, it's one button installation and you recognize each other, and then now you got the power and the I/O being integrated together on one data stream instead of having a power set and a workload set. And so some people say, well, what's a PAM look like, or what's it look like? And that's what these devices look like. They don't look like your typical system level work meter, which tend to look bigger like this projection box with a whole different set of levers and dials and readouts. So that's what these modules look like. Some people have asked, well, what's going to be my typical price point on this? And I think CTS Lite per seat or with the yearly plan is $7,000, I think, to start out, and then the PAM module's like about $2,000, and the other model's about 2.5K. So it's in the typical test and instrumentation level, and there's not an open source equivalent that gives this type of rich integration. So sometimes it's a trade-off of you might spend a little bit more on capital, but less on your labor of your engineering resource. And that's where that's at. Where some will say, well, VD Bench was free, but then you have to use all this labor then to mirror your data, so that you're spending it in an engineer's time. So, and that's one of the requirements that they get into regulatory-wise, that they don't want to keep any vendor at a disadvantage. So you take like a new upstart that might have innovative storage, and you want to understand that, can they test? Well, you can't make it price prohibitive, like you end up with like $100,000 test harness and tool set. So that gets you in the ball game. And when we look at the system, if we dial back to System 5, most companies already have like a power measurement meter already in house, but those run anywhere from $2,000 to $4,000 new, and on the used market about $2,000. And it's the same price for CTS Lite. So it's within budgets, but it's important for engineering departments to plan a budget to say how big and how many seats. And also for test I/O labs, because a lot of vendors also outsource testing as well. So switching hats, what's green community? Well, that's it used to be under the form initiative model that had a separate pricing structure, and that's where we would raise additional funds to buy extra engineering resources, buy equipment, and run tests. And SNIA has changed its model over to a more inclusive model, that one membership fee allows you to join any community that you want to inside of SNIA without any additional fees. So what does that mean inside of SNIA is that as we went through this consolidation of large system vendors, we lost a lot of the volunteers, because usually when you consolidate, you lose volunteers. And so this is reopened up the door to bring in a lot more people taking interest. So the last 6 months, we probably picked up about 30 more people that are interested in green. And what I want to do, in this part of my role and job, is to build these outward-facing programs, is start looking at what do we want to work on as a collective group, and we'll have a birds of a feather session tonight on other type of performance work that's going on that has power in it that could leverage our expertise. So we're going to get good presentations from SPEC on what they're doing with adding power metrics to their performance metrics, as well as from the Machine Learning Commons group as well, and they're adding power into their workload and then depending on who else is in the room, it's an open-ended discussion. So that's tonight at 7 o'clock around the corner in the other meeting rooms. And so sometimes when you go into these birds of a feather, everyone's like, why can't SNIA do fill in the blank? And I says, why can't we all together do that? Because there is no staff, there isn't no magic to this, because we're not a corporation. And this is where I always say, we is they. There isn't a we them, or I would have done it if they, SNIA, would have done it. So the landscape is the first two bullets say it all. We can look at, do we look at the data center, do we look at the application or the whole configuration, or are we looking at the specific ASIC or device? So the world's an open box here of what do we want to do inside or collaborate down the lines on the outside. And everything is come back to be green and efficient, and that's where we're at. SNIA's gone through, done the SWOT analysis, and this is some of the capabilities. We're real easy to build up new programs and alliances, and there's a lot of opportunity in this place. Inside SNIA to work together, as well as do alliances with existing work. Even when we get into alliances, it's like, well, we should form an alliance with that group. No, we need alliance managers. that can put a foot in each camp to make the magic happen. So that'll be talked about tonight. Resources, you have questions about anything you heard today, I'm a traffic cop on all this stuff and get you in the right place. Specific to Emerald, Dave Teal's our full-time program manager around this, and we'll get into training, support, problem, bug reporting. We have all that goes on. Our green technical work group co-chairs are Don Goddard and Carlos Pratt. And then we start getting into where some of the subject matter expertise come from. We have Don Capps coming from Spec, knowing all the file I/O, Ian Kim with the Calypso test suite, and knows hard disk drive and solid state device drives and how to get them instrumented to collect data. Andy Norrie's coming in from Quartz and is all about power measurements. Like he has test tools with the granularity that run circles around most of the other type of instrumentation in the market. He's been invaluable understanding how the more granular behavior works. And then in general, there's just the spec power measurement tool. So that's how we pull together all the expertise there. Any Q&A questions? No, I'm Chris. I can't repeat everything. Okay, you got skill, sir.
Well, I plan to look at the deck online because the decks we did online and there's going to be great information there. Just a reminder.
Yeah, beat me up on Thursday, I know. Yes, sir.
So you cover a lot. I think the one that I have a good struggle with is idle power. So
Yeah.
I find idle power is huge, right, in terms of whole systems.
Yeah.
I don't know what's in the idle power, and you mentioned some like it becomes really challenging, right? When you deal with a customer and they say, it's like power's so high, and then they run their traffic and it only goes up by a little more, and they come back and they say, why can't you get rid of this idle power?
Well, you learn in idle that when you start getting into the disk drive business, there's all this internal work that's going on with drives. Even with solid state drives, you might be moving data around if you've been overwriting too often there, so you don't want to wear. It's called wear leveling as an example. So you have all these background tasks and having vendors understand what they build into it, the Seagates and Kioxias and Western Digitals and that adds a lot of insight to say, well, why is my idle power so high? Because the systems are still doing work, so that when they are getting real work, the data, it's all about the data integrity. That's the biggest thing in enterprise. Is fast data that's ready to go, that hasn't been compromised. Clients, we tend to treat like, well, I made a backup somewhere else, and yeah, you're SOL for a period of time. So that's where idle comes into play. And then when you look at a system, if you've got a lot of cache in front of it, you may never touch the back end of your system, and so it may not be gone into this whole data movement where leveling error correction type or block correction kind of scheme. So you want to at least get everything stimulated, because then when the system hits a drive, say like you're a bank and you're running transactions from 8 a.m. until 5, and then it shifts into doing data backups in the evening. There might be some bottlenecks in your system because you're moving data off site and you got to wait for the NAC to go back and forth. To you might not be seeing like the data lights moving or your network lights when you're thinking the system is idle, but in reality your drive is still doing work. Well, it's not being toggled by an external I/O request. And so that's where idle power becomes important as well.
That's where I think I go back, customers will complain to me that it's not part of their workload, and then they push back and say, why can't you take it to zero?
Well, that's why we write. Yeah, so the question was like, why does idle stay high, and why customers can't get a break on this stuff? Well,
Zero idle.
so how we address some of that is we came up with a white paper that was in conjunction with the Green Grid, and you have to educate the outside market on this stuff so that you can then set some realistic expectation. Otherwise, it might say, when you hit the idle state, why don't you power off? Well, you might be asked to power right back on, and you take a whole system and you want to jump back on. You lose seconds, and you can lose the transaction, the value at the front end where it's at. Like, you're not going to sit at the gas pump, wait 3 minutes to be able to pump your card. So if it went idle, you still want to be able to capture it and still process it. And you want to get the right data back.
So what if power is more important than speed? In the sense that, for instance, I run a lab equipment. My lab equipment runs at 3.6 gigahertz, but I step everything down to 2 gigahertz. And then I also put power caps on it. And it means that certain things don't happen as fast as I want them to, because I'm sacrificing. But by going from 3.6 down to 2.0, you more than have your power requirements, even though you're not having your CPU builds. So that same prop running at a lower speed, idles at a lower wattage to it. And can you submit the same equipment in spec to get a spec number, both power cap and non-power cap? In other words, can it exist in 2 different bands for the same piece of equipment?
So are you helping me answer the question, or are you throwing another question at me? Because that was...
That is the question. Can a single piece of equipment be submitted for 2 different bandwidths and 2 different power numbers, both idle and high performance?
Yeah, you just...
Well, it could be more.
Yeah, so the short answer is, yeah, you can have the same, you have all these extra fields you can call out to say what's been activated or what's been set. Same way that, so the question is can I submit more than one report because I can set the power requirements to be with certain caps on it. It's the same thing as like capacity optimization. Even though the system's capable and you may not be running it, you may still run it with, like, say, RAID 5 instead of RAID 1 or RAID 6 or something like that. And what you're reporting is how's your system configured that when you ran the test. So right now, I would say the storage test, even with 100 systems, given all the variables you can set, there's probably going to be very rare you're going to be able to do apples-to-apples comparison at this point, as contrasted to running cert on CPUs, which is limited to like 2 and 4 socket tests that are very narrow with I/O.
Probably something we should carry to the Birds of a Feather session because we're out of time.
That's a good point.
It is.
When is the Birds of a Feather session?
That's tonight.
7 o'clock tonight.
Yeah, it's in here somewhere.
There it is.
There it is.
Hi.
Front and center. Get your coffee.
Sorry, I know I promised to ask you not to go back.
That's okay.
That's important.
That's here. All right. Thank you, everyone, for listening to me. I was glad to see no one fall asleep except the camera lady in the back. No. Yeah, thank you.